Starting our last learning target in Unit 3. So remember, Unit 3 is all about inequalities, which we've done a lot with so far, and about absolute values. So learning target 3C is where the absolute values will come into play. And we'll, in this video, be learning about absolute value equations, and then in part 2, we'll be talking about absolute value inequalities. So by the end of this video, you will be able to solve an absolute value equation. So an absolute value equation is an equation of the form absolute value of x equals a. Now, to solve an equation like this, we actually have to separate the equation into the negative and the positive parts. So the absolute value of a, this equation right here, is solved by splitting it into the positive part, which says x equals positive a, and the negative part where it says x equals negative a. So for these examples, we will now be getting two answers to go with them. And the reasoning behind why we have to split it into two equations is important to understand. And it comes down to this concept. If I take the absolute value of positive 2, I get positive 2 again. If I take the absolute value of negative 2, I also get positive 2. So because I can plug both the positive and the negative values into the absolute value, because remember we're solving for x, and because I can plug both positives and negatives into this, and I get a positive number out, then I have to take into account both the positive answer for x and the negative answer for x. Other key points to keep in mind for this is this equation that I'm starting with here. Whoops, that was a little messy. Let me not draw over a. Actually, a highlighter would be easier. So this equation that we're starting with, the absolute value of x equals a, already has the absolute value piece isolated. So x is not isolated, but the absolute value piece is isolated. So we always want to make sure that before we split into two equations, the positive and the negative, we first have isolated the absolute value part. The second is to split it up into two equations, the positive and the negative, like we talked about above. Then from there, sometimes we might have to do a little bit more work to actually solve for x. So let's look at our first example here. So example 1 says the absolute value of x minus 3 equals 7. So to be able to split into two equations, the positive and the negative, I first need the absolute value part isolated. So in example 1, is the absolute value part isolated? In this case, it is not, because the absolute value is just the absolute value of x piece. And so we have this minus 3, which is making it not isolated. So my first step will be to move the negative 3 to the other side by adding 3. So when I add 3, I get 10. So the absolute value of x equals 10. Now I have isolated the absolute value part. So my next step will be to split this into the two equations. The first one comes with the positive piece, so where x equals positive 10. And the second part comes with the negative piece, so x equals negative 10. From here, our x is also solved for at the same time, since x was the only thing inside of the absolute value, so we have our two answers. And both are answers of this. It's not one or the other, they are both correct answers. Okay. Let's do example 2. So in example 2, it says the absolute value of x plus 4 equals 6. So the first thing I need is to know, is the absolute value piece isolated? So you guys tell me, do you think the absolute value piece is isolated? Think about it. In this case, the absolute value piece is isolated because this whole term of x plus 4 is inside the absolute values, which means that I've already isolated the absolute values. They did it for me in the problem. So right away then, I can split into the positive and the negative. Now when I split this, remember up here, our x did not change. So it's x equals in both of these. So in this case, it will be x plus 4, since that's what's inside the absolute value. So in both cases, I get x plus 4. In the positive case, I get equals positive 6. And in the negative case, I get equals negative 6. From here, unlike in example 1, I have not solved for x yet. I have to do a little bit more work to get x by itself. So I'm going to solve each of these equations separately, because now that I've split it, they have nothing to do with one another, and I will solve each individually on their own. To solve the first equation, I have to move the 4 to the other side, so I'll be subtracting 4, and when I do that, I end up with x equals positive 2. And in the second example, I also have to move the 4 to the other side. So I will subtract 4 and I'll end up with x equals -10. Before we move on to our third example, I want to point something out that tends to be a common misconception. When we look at the definition up here that we have above, where we split into x equals positive a and x equals negative a, it's really easy to think that I'm always going to get the same number and I'll just get the positive and the negative of it. Now, that was true in example 1. That does happen sometimes. But example 2 points out that that doesn't always happen. So in example 2, I got one answer which was positive 2 and another answer which happened to be -10. So I don't get opposites of each other all the time. So it's important to make sure we're showing all of our work as we're going through, because we can't just assume that I'm going to get plus or minus the same number. That will not always happen. The other question I get a lot in class is, do I have to show this work of splitting it into 2 equations? Yes, this step right here, which I'm drawing nice blue highlighter arrows to, is absolutely necessary. We need to see how we can break that apart. The other thing I want to point out is that there are no more absolute values. Once you've split it into the positive and negative case, there's no need for absolute values because you're using the definition of what an absolute value is. The other thing that does not change is what's inside the absolute value. So the x plus 4 is still x plus 4 in both equations. What is changing is the number that we are setting it equal to. So in the positive case, it equals positive 6. In the negative case, it equaled -6. Okay, let's look at example 3. So I want you guys to pause the video and decide, is the absolute value part isolated yet, or do we have to do something first? Okay, in this example, the absolute value piece is not isolated. So the absolute value piece is the absolute value of x minus 3. And because there's this plus 2 on the same side of the equal sign, it is not isolated. So the first thing we have to do is isolate the absolute value of x minus 3. And we will do that by subtracting 2. And I get the absolute value of x minus 3 equals 8. Now that the absolute value piece is isolated, I can split this into the 2 equations. So I have the first case where I have x minus 3 equals positive 8. So this is the case where the absolute values just drop out and we get the positive 8. And the other case where I have x minus 3 still, so the x minus 3 does not change, equals the -8. So the second case is where the absolute values drop out and it is equal to the negative number there. Now in each of these we'll have to do a little bit more work and get x by itself. So on our first equation, I'm going to add 3 and get x equals 11. Sorry, I couldn't fit it directly underneath there. And in our second example, I'm going to add 3 as well, and we'll get x equals -5 as our other answer. So we have both positive 11 and -5 as our answer here. Okay, let's look at example 4. Is the absolute value piece isolated? Why don't you guys pause the video and decide if that absolute value piece is isolated. So in this example, it's a little trickier to tell. So the absolute value piece, I'm going to highlight it in yellow, is the absolute value of 2x. So that -3 is something extra, so I do need to go ahead and first move that -3 to the other side by dividing. So I have the absolute value of 2x will now equal positive 4, because -12 divided by -3 is equal to positive 4. Now that the absolute value piece is isolated, I can go ahead and break it apart into the 2 equations. So I'll have 2x equals positive 4, and the other cases where 2x equals -4. Now that we have it broken apart into our positive and our negative cases, I can go ahead and solve it by dividing through by 2, and I'll get x equals positive 2, and I'll get x equals -2 as my other answer. Okay. Why don't you guys pause the video and do example 5 on your own first, and then we'll check it together. So in example 5, the first thing I have to do is get this absolute value part isolated. So I'm going to divide through by the 2. So I have absolute value of x minus 1 equals 4. Now I can go ahead and split it into 2 cases. The first case will be the x minus 1. Remember, the stuff inside the absolute value is never going to change in this step. So I get x minus 1 equals positive 4. And then the other case where I get x minus 1 equals negative 4. Again, that stuff inside the absolute value, so the x minus 1 does not change in this step. From here, I can go ahead and solve both equations for x by adding 1 to both sides, and I'll get x equals 5, and I will get x equals negative 3 as our two answers for example 5. Okay, why don't you guys pause the video again and do example 6 on your own first, and then we'll check it together. Okay, let's check example 6. So I'm going to go ahead and highlight our absolute value piece just to make it a lot easier to see. Our goal is to have that absolute value piece isolated first before we split into two equations. So I first need to add the 6 to the other side. So I get the absolute value of 3x minus 2 equals positive 8 when I add the 6 to the other side. From here, I can now break apart into my two equations since the absolute value part is isolated. When I do that, we'll get 3x minus 2 equals 8, so the positive case, and we'll get 3x minus 2 equals negative 8, so that negative case there. Okay. Again, it is necessary for you guys to show this work so that you can demonstrate that you understand what it means to break apart an absolute value equation into the two pieces, the positive and the negative. And don't forget that whatever is inside the absolute value, so the stuff that is inside here, so 3x minus 2 will not change. It is just changing the sign on the number we're equal to. Okay, to solve our first equation, I need to add 2. So I get 3x equals 10. And I actually have to do one more step to get x by itself, which is divide through by 3, and we get x equals 10 over 3. I cannot reduce that fraction down anymore, so there's one of our answers. The second answer, our second equation we can now solve. I'm going to add 2 to both sides and get 3x equals negative 6 in this case. And again, I got to divide through by the 3, so we get x equals negative 2 as our other answer to example 6. Okay, question 7. So again, I'm going to have you guys pause the video, try our last example on your own first, and then we'll check it together. Okay, let's check example 7. So our absolute value piece is the absolute value of 2x plus 1, and we need to first make sure that that term is isolated. It is not in this case, so I first need to add the 3 to the other side, and we get the absolute value of 2x plus 1, all inside absolute values, equals 16, since I have to add the 3 to the other side to isolate the absolute value term. Now that the absolute value term is isolated, I can go ahead and break it apart into the two equations. So our first equation will be 2x plus 1 equals 16. So that's the positive case where all we do is get rid of the absolute values. And the negative case is where we get rid of the absolute values. So 2x plus 1 does not change, and it is equal to negative 16 in this case. From here, we can go ahead and solve each of these for x. So I'm going to subtract 1 to get 2x equals 15, divide through by 2, and x will equal 15 over 2. So there's one of our answers. Our second answer, we're going to subtract 1 again and get 2x equals negative 17, divide through by 2, and we get x equals negative 17 over 2. Neither of those fractions can be simplified down, so we have our two final answers there for our last example. The next part of this learning target will focus on what happens if I have an absolute value inequality, and we'll talk about that in our